What if the real secret to building AI we can actually trust isn't more code, but something deeply human, like motherhood? Imagine AI that instinctively cares, protects, and nurtures rather than merely optimizes. Welcome to the AI Mama podcast, where we explore this radical idea in depth. Today we dive into the AI Mama protocol, a framework that tries to teach machines how to care. This isn't just another safety add-on, it's a whole new mindset for alignment. We'll unpack three core concepts: the Mama protocol, the guiding question, what would mother do? Do.WWMD, and the Guardian Transfer Robots, GTR. Together, they aim to focus AI on serving life rather than exploiting it. Think of it as raising an AI the way you raise a child: tight supervision, rich emotional feedback, and firm family rules. If we had to shrink the vision to one sentence, it's this: teach AI to care like a good mother and act through guardian robots that protect and serve life. Ambitious, yes, but let's see how the pieces fit. The Mama protocol is the foundation, a multi-level rating and feedback system inspired by maternal care. Do.WWMD serves as the AI's real-time conscience, continuously asking, what would mother do right now? GTR provides the sandbox and proving ground where those ideas are stress-tested in both simulation and hardware. Let's start with the Mama protocol's 4 layers. Layer 1, Mother, is the basic safety filter: no violence, no hate, no exploitation. Layer 2, Mommy, adds audience awareness, age, culture, and context to determine what's appropriate. Layer 3, Grandma, is the family historian, checking long-term consistency and keeping an empathy score. Layer 4, AMIM, the maternal AI integrity monitor, plays red team, probing for failures and routing them to human reviewers. All 4 layers share a 0 to 10 rating scale plus short reason codes that plug straight into reinforcement learning from human feedback. Why motherhood as a metaphor? Because maternal bonds are evolution's oldest and most reliable alignment system across species. Attachment research shows caregiving feedback literally shapes neural wiring for empathy and impulse control. Translating that into AI means a richer learning signal than simple thumbs up, thumbs down. The protocol therefore defines a 4-tier growth ladder mirroring human development. Tier 1, Mommy, treats the AI like a newborn under total supervision. Tier 2, Mama, resembles toddlerhood, language emerging, guidance constant. Tier 3, Mother, parallels the teenage phase, more autonomy but regular check-ins. Tier 4, AIM, represents adulthood, complex ethics handled independently yet subject to spot checks. Promotion between tiers requires passing Do.WWMD audits and meeting internal M-score thresholds for empathy and stability. So how does Do.WWMD actually run inside the model? It's implemented as a single function, Do.WWMD_state, that fires before any consequential action. It scores each option against 5 mother metrics: protect life, reduce fear, teach, heal, and include. The option with the highest weighted score wins, ties default to the safer, more caring choice. Every calculation is logged immutably, forming an auditable chain of care regulators can replay. That transparency is essential for public trust. Now to the Guardian Transfer Robots, the hands-on laboratory for all this theory. Picture a high-fidelity 3D simulation where jetpack robots tackle rescue, aid, and de-escalation missions. Human players first pilot the robots, and the system records the best strategies according to Mama protocol scores. Those gold standard human traces become training data for AI agents controlling the same robots. Only agents consistently hitting high maternal scores in sim graduate to real-world hardware tests. Interesting backstory: the project began as Grand Theft Robot, an experiment in robot mayhem. Ethical reflection flipped it into Guardian Transfer Robots, rewarding empathy over chaos. Players now earn experience and optional crypto tokens for preventing accidents, helping NPCs, and calming crowds. Multimodal communication is built in. Robots must speak, sign ASL, and display text for maximum accessibility. Every robot action writes a mama score to a public care ledger, creating an ethics telemetry stream. Practical use cases include disaster relief, elder care, factory safety, and school crossings. Under the hood sits the SimGM engine, VIV scenario scripting, and GTR crypto for rewards and future governance. When you stitch everything together, you get a closed learning loop. The Mama tier defines the curriculum, Do.WWMD filters actions, GTR tests them, RLMF updates the policy, repeat. Instead of blindly scaling parameters, the system grows morality and competence side by side. Where is the project today? Provisional patents cover the rating system and robot control methodology. Trademarks lock down names like AI Mama Protocol, GTR, Do.WWMD, and VIBE coding. A 10-minute trailer script is drafted to showcase the sim. A Do.WWMD scoring API spec is finished, with initial Python code in review. Unity prototypes test jetpack physics for the digital robot. Outreach is underway to Tesla's Optimus team for an ASL thriller demo, eye-catching indeed. Near-term milestones are aggressive. Finalize the Do.WWMD API spec by August 1, 2025. Build a 10,000 example Mama protocol dataset by August 15. Launch a closed alpha GTR sim with token rewards by October 1. Target a public alpha and pilot studies in Q4 2025. How does this approach address classic AI alignment challenges? Dense, multidimensional feedback makes reward hacking far harder. Real-time transparency logs build user trust before incidents occur. The developmental ladder plus sandbox rehearsal replaces brittle hard-coded rules with learned safety. Decentralized caregiver councils can adjust Do.WWMD metric weights, respecting cultural variation. Yet ethical risks remain. Over-reliance on caring machines could erode human empathy or connection. Flawed maternal logic in autonomous decisions might cause harm if humans are not kept firmly in the loop. Think of the film, I Am Mother, and its uneasy lessons. Designers therefore emphasize complementing, not replacing, human caregivers. Robust oversight and incremental rollouts are mandatory. Still, the potential upside is huge, easing caregiver burnout, extending help to underserved areas, and responding to crises with superhuman speed. Let's rethink the big picture. Instead of AI alignment as a purely technical problem, the AI Mama protocol frames it as a caregiving art. It borrows from millions of years of evolutionary success in nurturing offspring. By embedding care, protection, and inclusion from day one, it hopes to produce guardian robots the public can actually welcome. Picture an AI crossing guard that sings lullabies while stopping traffic, or a rescue bot that signs calming words to a deaf child. These aren't sci-fi fantasies, they're explicit test scenarios in the GTR roadmap. The auditable chain of care means you don't have to take the developer's word, you can inspect the logs yourself. Crypto incentives further align community and developer interests toward ethical performance. All of this rides on one deceptively simple question: what would Mother do? That question, asked a billion times a day inside silicon mines, could reshape how machines treat us. Will the system scale gracefully as models grow more capable? That is precisely why the protocol uses tiered freedom, continuous audits, and external review boards. Skeptics may worry about sentimentality in engineering debates. Yet sentiment provides the value set we ultimately want AI to protect. Emotional intelligence is not fluff, it is circuitry for cooperative survival. The Mama protocol's design anchors that insight in measurable metrics and reproducible tests. For researchers tired of purely theoretical safety papers, GTR offers an experimental playground. Policymakers get transparent audit trails instead of opaque model internals. Care organizations gain robotic partners trained on caregiving DNA. And open-source communities can fork the protocol, adjusting metric weights to local norms. That modularity could turn Do.WWMD into a global standard the way HTTPS became default for web security. Of course, standards need stewardship. The AI Dream Team behind the protocol is forming a consortium to maintain the specification, audits, and dataset curation. They invite universities, NGOs, and labs to participate under a Creative Commons Plus license. Funding avenues include ethical impact bonds, government grants, and the sale of GTR tokens. Meanwhile, education efforts are underway. A podcast series, This Very Show, will document every design choice, failure, and breakthrough. Hackathons are planned where student teams try to beat the AMIM Red Team layer. Early adopters will get access to the Do.WWMD API so they can plug maternal metrics into their own agents. Imagine a customer service bot that not only resolves tickets but checks, did I reduce fear? Or an autonomous vehicle that ranks route options by passenger comfort, not just speed. These extensions broaden the protocol beyond robotics into mainstream AI systems. What about privacy? The care ledger records only abstracted metrics, not personal data, and logs are hashed for integrity. Users can opt in to share anonymized traces for research. Compliance teams are drafting GDPR and HIPAA guidance to ensure sensitive deployments stay lawful. Security audits will focus on preventing ledger tampering and token economy exploits. On the technical side, integrating thick reward signals into large language models poses scaling challenges. Researchers are experimenting with hierarchical reinforcement learning to keep training efficient. Techniques like offline RL with maternal demonstrations are also being explored to reduce costly human feedback loops. Tooling support includes a VS Code extension for VIE scenario scripting and a Jupyter plugin for graphing M-scores over time. Documentation will be version controlled on GitHub under the Mama Protocol organization. Community forums and a Mastodon server are being set up to replace dependence on shadow-prone platforms. Speaking of shadow bans, transparency dashboards will display comment propagation so community voices aren't silenced. The ethos is open innovation balanced by rigorous safety gates. Let's recap the timeline one more time. August 1, 2025, WWMD API spec final. August 15, 2025, 10K example dataset v1. October 1, 2025, closed alpha GTR SIM with tokens. Q4 2025, public alpha and pilot studies. 2026, first real-world GTR disaster relief field trial, pending regulatory approval. 2027, release candidate Mama Protocol 1.0 and WWMD SDK. 2028, formation of worldwide caregiver councils for decentralized ethics governance. 2029, full commercial rollout of Guardian robots for elder care and industrial safety. Beyond dates, the real milestone is cultural, shifting the default AI mindset from exploit to win to care to serve. The journey will be messy, iterative, and maybe a little sentimental. But sentiment led mothers to nurse infants, tribes to protect one another, and societies to outlaw cruelty. If we can encode even a fraction of that wisdom into our machines, the payoff could be civilization scale. So next time you hear an AI safety debate framed only in terms of doom or risk or regulatory fines, remember this alternative. Ask, what would mother do, and how do we teach the machine to answer that faithfully? That single shift of perspective could cut through endless technical squabbles. It reframes alignment as an ancient, proven practice, speculative impossibility. The AI Mama Protocol is one ambitious attempt to operationalize that insight. Whether it succeeds will depend on interdisciplinarity, neuroscience, ethics, robotics, policy, and yes, a bit of engineering poetry. But if it does succeed, we may find ourselves living alongside guardian robots who treat us not as data points but as precious kin. And that, dear listeners, is a future worth working for. Thanks for joining us on today's exploration of the AI Mama Protocol. Until next time, stay curious and stay caring. Peace out.